the products that you get come from an American factory or are received at an American port, travel on a truck before they get to you, sometimes multiple. A good example is medical supplies. According to an IRU.org report, within 1 day of no trucks, hospitals run out of a supply of clean linen, and pharmacies will have some drugs that are short supply on the shelves.
And example 2 is gasoline. It doesn't take much for people to start freaking out when they can't get access to gasoline. We saw that in 2021 with the Colonial Pipeline attack, that when people can't get access, they start going wild. Anyways, heavy trucks actually play a really key role of getting gasoline to gas stations.
That's right. Another good example is drinking water. Some remote communities actually get their drinking water via truck, and everyone's water treatment plant gets their treatment chemicals via truck.
Worldwide, 72% of products move via truck.
From that same IRU.org report titled Week Without Trucking, they estimate that after 4 days without trucks, garbage pickup stops, public transportation stops, and air traffic stops, because all of those services rely on a constant fuel resupply from trucks. And on the 5th day, your drinking water may not be safe because of a lack of supply of water treatment chemicals. If you bought it, it came on a truck.
It absolutely did. So Ben and I have been working together, and we have identified several similarities between ICS and the fleet industry. And we're really excited to share all these similarities because we're hoping to lean on each other, learn from each other, and kind of share our experiences and grow. And potentially, maybe we can create the future for the heavy trucking fleet.
Yep.
At a high level, the similarities are that both of us rely very heavily on electronic components. In ICS, we might have PLCs to automate our industrial processes, and in heavy trucks, we have ECUs that will automate engine control and monitoring.
That's right. And both industries have to comply with strict safety regulations and standards. In trucking, we have to comply with road safety standards from the FMCSA. And in ICS, you have to comply with standards from OSHA and EPA. Yep. And both industries have a shortage of skilled workers. And as the systems that they have to operate get increasingly more complex, obtaining the right training for the existing workforce becomes very important to operate the equipment safely and efficiently.
And there are also some key differences, like the specific equipment that we use and also some of the places that we are. So for fleets, they mostly focus on logistics and transportation, and in ICS, it's just in automating industrial processes. So there may be, the fleets are on the highways and roadways, and in ICS, we're mostly in chemical plants that might have different conditions or potential hazards. There's some other similarities also around the culture. In heavy trucks, they have years and years of components that they might not swap out, maybe 15 or 30 years before they'll swap out a piece of equipment. And in ICS, we're also used to some of these older pieces of equipment. You might find in a plant that you accidentally leave a gate open so that contractors can get their work done. Similarly, all the fleets have the same truck key to get into the door. I think also our approach to bringing donuts to get to know the engineers will be something that applies really well for fleets.
Yep. Yeah, whenever I do testing, I always bring donuts.
You got to.
Yep. So there is a lot of similarities, and I've had the pleasure of talking with you about this for quite some time. And last November, we actually presented this concept to a trucking audience where we gave them, the similarities, the tools, and other techniques from ICS. And we gave them a bit of a Rosetta Stone that we thought they could use to translate between the two spaces.
Absolutely.
We're going to do roughly the same for you here, except we're also going to show you threats to trucking, because that's a topic that audience already knew about. Our goal today is that you leave with a better understanding of threats to trucks and feel comfortable exchanging information between the two domains. We think ICS has already gone through the growing pains of applying a lot of security controls, and by sharing information between the two, you might help the fleets fast forward through some of that pain. So because we've already promoted this idea that they could use ICS resources to help them level up, we're hoping that you will start seeing them at your conferences and your trainings and information sharing sessions.
Absolutely, and if you see them, we would hope that you would share your story of how you've been able to improve product security, to work with vendors, and really push the needle forward for having a better and more secure product without compromising on availability or cost.
So there has been a lot of research into threats to heavy vehicles. But first, I do want to thank you, Kate, for connecting me to this conference so that we could be here and do this. So thank you. Researchers such as Bill Haas, Eliza Borakova, Subhajit Mukherjee, Andrew Kongs, James Johnson, Chris Poore, and Urban Johnson have published research about these attacks. Now remember, these are public pieces of research, and there's all sorts of stuff that goes on under NDAs that otherwise is not disclosed, so we should treat this as the tip of an iceberg. Starting with J1939, there are several ways to do denial of service, and one of the things you can deny is the instrument cluster, which is a Car Hacker's Handbook classic.
I think it's important to note that J1939 isn't just used in heavy trucking, it's also in heavy mining equipment, it's in agriculture and tractors, and it's in maritime and all the ships, and potentially several engines. But it's basically any mode of transportation that relies on a large diesel engine.
That's right. And these diesel engines are designed to fail safe into something called a D-rate. And in a truck, when there's a D-rate, that also results in a limp mode of the vehicle. And at first, having a limp mode as the result of one of these attacks, be it by DEF, which is the additive for the exhaust in a truck, or fuzzing in the proprietary space, or reconfiguring engine limits, at first it seems like ending up in a limp mode is not an issue because it's a fail-safe. But the problem is that it can be a big problem to the fleets, and a little bit more on that later. Yes, next up is 1587, which is a much older protocol. Here, there are a few attacks that involve diagnostic replay to turn off engine cylinders, for example, and to cycle ABS air release valves. Note here that the malicious code on ECM threat doesn't actually mean executable code. In trucking, the term reflash actually means reconfiguration or reparameterization. So here, this malicious code just means reflashing the ECU, which is reconfiguration. And that's all through diagnostics replay, which brings us to J2497. There, you can also cycle the ABS release valves, again, through diagnostic replay. But depending on the equipment configuration, you may actually be able to do that wirelessly from up to 12 feet away.
Well, it's a good thing we don't have balloons that will be too close to handle it. So these attacks have not actually been seen in the wild. They are publicly known and they have been proven. I think the important thing to note here is that all of these vehicle network types have the ability to have something like a denial of service or even limp mode on any of these types of vehicles.
Yeah, that's right. And they are all serial networks, which you should be familiar with.
Absolutely. In ICS, we use serial all the time. So you should be very familiar because all of these protocols run over serial.
That's right. So there is like 3 possible serial networks on trucks today. Every truck has 2 of these. CAN and a power line, which is for the tractor-trailer connection. And some trucks today still ship with the 3rd older protocol, the J1708. On trucks, the CAN network in particular is J1939, which has a high-speed and a low-speed option. The high-speed is available on green connectors, and the low-speed is available on black connectors. And these connectors are actually designed so that you can't incorrectly connect an older diagnostic adapter into a newer bus's green connector, because it would actually make the network fall over. And it's pretty clever, and it's a really good example of the kind of thought that goes into enabling the maintenance teams of the fleets. These maintenance teams of the fleets are really important. They have to do diagnostics and reflash day in, day out to keep the trucks running smoothly and keep the business making money. So even though J1939, like all CAN networks for vehicles, was introduced to replace the analog signals that used to be traveling around on pairs of wires in the vehicle with time-varying packets, it also inherited a large part of diagnostics and reflash. And if the reflash reconfiguration is done incorrectly, that can actually result in D-rate events. And these D-rate events can be bad enough for the fleets. I know I keep saying that. I'll say why later.
Yeah, I was going to say. It also means it's stopping production. It's
That's
not
a big
just
part of it. Yeah,
Yeah.
it does stop the truck from getting where it's supposed to go on time, which is a big part of it. And we'll say more about that a little bit later. The J1939 is used, like all CAN networks, to realize a distributed control system. So these distributed control systems actually react and respond to the messages on the bus, and they trust them implicitly. And this is part of the reason why the denial of services on CAN and on J1939 are really possible. Even though the simplest form of denial of service, where you just send all zeros, which is the highest priority CAN frame, actually has mitigations in some recent CAN controller silicon. The good news is that the diagnostic and reflash features that are the other big part of 1939 are protected by something called seed key exchange, which is a challenge response protocol that allows people to get authorization to do those more dangerous or privileged features. Ideally, seed key exchange would be cryptographically sound and would be resistant to attackers that have access to the bus, possibly control of it as well. Practically speaking, though, the the implementation of seed key exchange looked a lot like what's in passenger cars, which means that it was made to resist unauthorized reproduction of diagnostic software and not necessarily to resist an adversary.
We've had a lot of problems with cryptography as well, mostly because our PLCs don't generally have the processing power to do cryptography over long distance in real time.
Yeah, the J1939 engine control loops have evolved over time as well for their processing power. And even though when the control loops got out there, they started using the J1939 messages as defined in the standard, they've migrated to higher resolution and higher data rate messages that are held in the proprietary space. So today's control loops really listen in that proprietary space, which is one of the reasons why some research by CAN Bus Hack, who did a simple fuzzer in the proprietary space that caused D-rate events, was so successful. In J1587, there is also proprietary space messages. This is a much older protocol, and there the proprietary space is just unicast, point to point. There never were any control loops that were listening in that proprietary space. Instead, proprietary space there holds diagnostic and reflash, those important fun stuff if you're a hacker. And in J1587, the key is there is no seed key exchange. There's no replay protection at all. So diagnostics replay there is effective at making bad things happen. Which brings us to the PLC protocol.
Not the programmable logic controller protocol.
No. There's no ladder logic here. This is a power line control protocol. It was introduced solely for the purpose of bringing trailer fault information all the way up to the cab on an existing connector that they weren't allowed to add extra wires to. The problem, and this was actually introduced after J1939. The problem here is that it was implemented by creating bridge chips, bidirectionally converting between the existing J1708 that was decades old at the time and this power line communication network, which meant that vendors could take old microcontrollers with existing 1708 code and stick a bridge chip in front of it, and now we have the same problems with 1708 or 1587 on a power line network that is both remotely readable and writable with radio energy.
So that was a lot, but we have now just covered all of the protocols you might find in a truck.
Yep.
So what does that leave us with?
It was a lot. So here's the takeaways. Any software that connects to one of these serial buses is capable of sending messages and having the ECUs react and respond to those messages. It's trusted implicitly. J1939 has evolved to use the proprietary space messages for their control loops, which is why fuzzers in the proprietary space are so effective. And then finally, the stuff that isn't control loops, the reflash and the diagnostics, is protected by seed key exchange. And ideally, seed key exchange will be better than passwords. But practically, seed key exchange has been a break once, use everywhere, and so unique passwords would have actually been better. Fleets have to use equipment up to 30 years, 15 to 30 years. You're going to hear me say that a lot. And that means that all the results of 1708 are relevant to fleets rolling equipment today. And there are fleets that do have telematics adapters that convert to 1587, and they have their telematics connected to those buses, and there's no segmentation and no replay protection whatsoever. And finally, that power line connector between the tractor and the trailer is not going to go anywhere. When they added power line communication to that connector, it was the same as it was in the 1960s. And that connector is going to have to be the same for the next 30 years to service that equipment.
So in summary, we've been able to replay diagnostics, we've been able to replay command and control messages, and we've been able to spoof messages in the proprietary space. All of these things are going to cause either a denial of service or a limp mode for these trucks.
Yep.
Yeah, but we know one way to mitigate that, and that is through segmentation. So we've kind of designed this diagram of little options for OEMs to be able to use, and it's got, how you would read this. Vertically it can communicate, but horizontally it should not. So for ECUs, they can talk to the sensors and actuators, but they can't necessarily talk to the telematics devices. And we put little dotted lines around the gateways because they're kind of optional, and their kind of implementation is optional as well.
Yeah, the diagram is a bit of an idealization.
Absolutely.
There are definitely trucks out there on the road where what you have is a bar across the top and everything can talk to everything. But it's true that the OEMs today are definitely fielding trucks that have gateways on them. But again, because the fleets operate equipment that's 15 to 30 years old, we do think that bolt-on gateways are something that fleets are going to have to deploy in the near future.
Well, but it's not to say that they're without segmentation today. They just have it more as a performance reason and less for a security reason, much like our industrial gateways versus industrial firewalls.
Yeah, that's true. The gateways are, present, and I've been on trucks that are very new and connected up to it and then perform brake diagnostics, which, might be valid for how they shipped it, but isn't what a security gateway should do by default. So we think that defining what is allowed and what's not allowed through gateways for the segmentation of aftermarket particular would be really useful. And it would actually help both with defining what an aftermarket gateway should do, but also what these bolt-on gateways should do. Now note that an aftermarket gateway is not a device that a fleet has installed in the aftermarket. It is a device that OEMs put on their truck to separate aftermarket devices from their vehicle networks. So it's a bit of a nascent topic, what should be allowed and what shouldn't be allowed. The definition of this is an ongoing effort happening in the American Trucking Association's Technical Maintenance Council Task Force for RP 1226 message standardization. And we are also publishing security gateway requirements, which we put out as an interim report as part of our ongoing work to define a complete set of cybersecurity requirements for a whole Class 8 vehicle, which is a project that we're calling the Truck Matrix.
Which sounds like a whole bunch of different variations that OEMs could have. I'm thinking like ICS can help from like an SBOM perspective. Please. You put configurations and you catalog all of them. I'm not sure if we could help with that, but we could try.
I mean, half joking, SBOMs are magical. Maybe they can help, but also maybe you can, and we are accepting volunteers to try to define that full set of requirements. That's definitely valid and would be welcomed.
Awesome.
Very welcomed.
Well, so I'm curious, how are these things supposed to scale? So we're going to attack these trucks, but how would I attack a fleet of them?
Yeah, in short, telematics, right? So generally speaking, telematics devices are connecting vehicle networks to the internet. Ideally, that connection is only to authorized data sources and doesn't include access to any of the cyber-physical systems in the truck. But practically, not all these telematics devices are really created equal. They're not of the same quality. So trustworthy or not, these telematics devices are putting the vehicle network on, or at least close to the internet.
When you say on the internet, you don't mean the actual routable internet where people can connect to it, do you?
It's an excellent point, and there definitely are high-quality telematics providers that do have cellular carve-outs where they have like their own, routable space, and that would be excellent. But that would be the exception, not the rule. The connectivity on these telematics devices is really across the board. And not just for internet connectivity. Some of them use like Bluetooth tethering to get their internet connectivity. Some of them stand up their own local Wi-Fi hotspots, web servers, and they might have unencrypted traffic and unauthenticated Bluetooth services. I mean, all that IoT stuff.
I feel like we see a lot of that in the plants, and people bring their own,
So it's rough all over?
It's rough all over.
So to pile on a little bit, because telematics is easy to pile onto, some of the service providers actually use white label devices. So the fleets don't even realize what issues they're inheriting from these seemingly unrelated devices. The Sierra Wireless modems talk from 2018 at Black Hat is a really good example of that.
So relevant.
As is Sam Curry's recent research and friends, Sam Curry and friends, November 2022, where they found that there was Spirion admin access on the web backends. And some of the devices are just terrible. Electronic logging devices, ELDs, were actually allowed to self-certify, which led to all kinds of hilarity. And for details on that, you can look at Corey Thuen's talk at IOASIS in 2018 as well. I think he used to run the CTF here.
Absolutely. And I think next we're going to kind of go over, we just mentioned ELDs, but we use them in kind of similarly as a historian. We'll collect all that data, we'll send it to compliance, but we'll also use it for performance, we'll use it to enhance things, preventative maintenance, just analyzing trends, where you guys use ELDs for?
Just compliance. Yeah. The electronic logging devices were introduced to satisfy a regulation about hours of service, which is to make sure that drivers don't drive too long, they stay alert on the road, and all the road users are kept safe, which is very important and is a whole department in the fleets to make sure it's complied with. But all those other features you mentioned, which are really great, are not there. And this is one of the things that we think would be a really great feature to have on trucks, especially for like forensic analysis should attacks happen.
And if you're a vendor out there trying to sell Historian, you should talk to Ben afterwards, and maybe he'll buy it, or his members will buy it.
Members may buy it.
Your members will buy it. How about an ECU?
Let's do PLC ECU comparison. Okay, so in ICS you have programmable logic controllers, and they're responsible for automation and monitoring of the process in your plants, right? And we have ECUs, which were engine control units, but has been retconned to be electronic control units, and they're responsible for monitoring and automation of the entire vehicle.
But who actually puts the logic on the ECU?
Yeah, and that is where it gets different, because PLCs, you get to put whatever code you like on them, you're in full control. ECUs, the code comes from tier suppliers or OEMs, and they get to decide what executable code is. The fleets can only change the parameterization. And in modern ECUs, that code is actually signed with Secure Boot.
How about an HMI? I hear you've got one of those.
Yeah, we got HMIs, steering wheels and horns. A pretty obvious one.
Yeah, that seems pretty obvious. Another obvious similarity is that you've got a business network on top of it, so you kind of have the separation of the OT and your business network.
That's right.
Yeah.
So there's a lot of IT at fleets, and fleets exist at a whole bunch of different scales. The biggest ones and the most efficient ones actually have their own in-house software developers, and they'll implement all that IT infrastructure to make the business run. Here's an architecture diagram that we put together about an LTL fleet, which is a less than truckload fleet. In the bottom right, you're going to see dark blue boxes representing the distribution centers, how freight gets broken and reloaded, put onto trailers, etc. In the bottom left, you're going to see that diagram of a truck. Again, the rules for the architecture diagram are the same as before. Communication can happen vertically, but not horizontally. The upper half of this diagram in its entirety is the IT system of a fleet, and you can see it's quite extensive. So let's look at some of the similarities. First up is what I've been talking to you about so much already today. The trucks are built with standard protocols and a little bit of proprietary extensions, which is a lot like ICS.
Absolutely. This might actually look a bit more like an unmanaged substation, but yeah, we've got standard protocols with proprietary implementations and extensions all over the place.
So let's look at the maintenance and distribution center. The fleets all have multiple maintenance centers and multiple distribution centers that they operate like a network across North America.
And we've got several different operators and plants and substations across the area as well.
There you go.
It works.
Very similar. In fleets, they have specific departments that are responsible for compliance, to lots of regulations, including the hours of service regulation we just talked about. They also have departments for safety, and their safety department does things like coach their drivers to make sure that they're safer on the road day by day. But there isn't usually today a place where the cybersecurity responsibility for the rolling assets squarely sits. And sometimes we've seen it fall under IT, and sometimes it's both departments pointing at each other. And I believe ICS already went through that and they're past it, right?
Absolutely, and I think now we're starting to name a person to be in charge of OT security for their environment.
Very good.
Absolutely. So next I want to talk about sensors and actuators. In ICS, we don't normally consider that data specifically confidential. It kind of requires the context of the logic, where it actually is in the process, and really what it's used for before we would kind of say what it's worth.
It's true, but in vehicle networks, partly because it's all standardized and well-defined, there's a lot of confidential information flowing around in a vehicle network. For example, there's geolocation traces on that network. And if you had all those geolocation traces, you could actually infer things about their routing strategy, and how they respond to weather events and traffic events is actually fleet competitive advantage. So that would be very bad. The other thing is there are signals on there that are proxies for cargo volume. And if you can estimate cargo volume of fleets, you can actually front run their earnings reports like Deutsche Bank did to XPO a couple years ago, and that doesn't make anybody happy.
Not at all.
No.
I think another talking point between the two groups could be cellular, use of cellular. Yeah. Both of us use it very heavily, and I think we could all talk about our implementations and what's working and what's not.
Yeah, and fleets have actually been a mobile-first production system in your terms since the beginning of telematics, which has gone back to satellite, long time. So I think fleets are actually leading ICS in that regard. Right, and so all of that compare and contrast together that we've done, that's kind of the Rosetta Stone that Kate and I have been thinking about.
Absolutely, and now that all of you know how to speak the same language, how would they go about talking and doing this assessment?
Yeah, well, I can tell you that you shouldn't do it like any old IoT pen test. We know of a particularly bad case where a service provider focused exclusively on hardware reverse engineering of a telematics device, even going so far as to reverse engineer pinouts, instead of considering how the impacts here or on the truck could impact the whole business at large, like crown jewels analysis.
Yeah, and last November when we were working through this, we did our own crown jewel analysis on the industry, and we found that trucks aren't even the most important asset.
Nope, it's their drivers. Their drivers are critical to their operation, and their safety is of paramount importance.
And safety has always been number one for us, right? We've always cared about that. And as we implement security controls, we have to remind ourselves it's really important that the people do not panic.
Yeah, so you've heard me kind of allude to this already, and I dodged the question earlier.
You did.
But the reason why limp mode is such a big deal to fleets is their people. Having a driver be forced into a limp mode on a full-speed freeway can be a harrowing experience. And then more than that, through word of mouth, that could actually lead to losing confidence in just more than one driver, which could be a really big issue for a fleet. So the schedule, the prioritization for fleets really goes their drivers, then real estate, and then their trucks are somewhere in the middle of the pack, except where the truck issue impacts the people.
Would you say that that prioritization would be the same across all of the fleet industries?
Unfortunately, because it would be nice if it was simple, but it's not so
Of
simple.
course not.
Every fleet is a unique business. You can kind of think of fleets as like a scatter shot through this 3D space that I've charted here for you. There's different equipment that they can run. They might have different types of carriers. There may be a private carrier or a public carrier, for-hire carrier. Or they might have different freight, like are they LTL, less than truckload, are they truckload? We don't really have time to get into it here, but the thing that influences their prioritization the most is that bottom axis. What kind of freight do they have?
And you can actually reference the fleet concerns deck that we have here, and it's got a whole bunch of information on how to determine which fleet and what impacts there are.
And we recommend you should talk to them about it at the beginning of your engagement.
Absolutely. So we also have a whole bunch of resources for you. The Cybertruck Challenge is a place where students can assess heavy trucks and they get their hands on trucks. And we as instructors help them through that.
Yeah.
So all of the training from previous years are there, and also a bunch of information from the NMFTA.
Yes, the cybertruckchallenge.org website has a lot of really good resources. As you can see, whoever was presenting actually clicked the link and would go to the resources. That's how good it is.
Yeah, right? It already happened.
You know, there's previous slides there from trainers in previous years. Hannah De Silva has a talk, slides up there on how to use her Truck Devil platform, and that has details of J1939, her tool, and how to use it to do assessments on trucks. The NMFTA website has our truck hacking deck, which has details on all the vehicle networks and a selection of tools that you can use to interface to the different vehicle networks. As well, the NMFTA site has links to our Git repo and our work groups and all the works in progress and previous work products thereof, like our truck matrix.
Absolutely, and they also have a whole bunch of stuff for their IT side as well on there. Yeah.
That's true. IT is a big part of securing, and just like it is in ICS, we need to think about IT and OT at the same time.
And while we were at the conference last November, I got a chance to talk to all the people in the fleet, and several of the people there were really excited about coming to conferences like this, learning from ICS, learning from all of you, and hopefully they'll see them here.
But will they see you at their conferences? We think there's a lot of expertise that you have in this room, having lived through 2 decades of applying security controls to industrial control systems. We think there's a lot of similarities and parallels here. We hope that you see them too, and we hope that you might choose to get involved. One of the ways you could do that is with some of the NMFTA working groups, where we're doing things like cybersecurity for trucks and other technical considerations that help feed into standards development.
The Cybertruck Challenge currently has mentorship applications open in case anybody would like to mentor students on how to hack trucks.
Yep. You could come and join us at the next cybersecurity event the NMFTA is holding in October 21st, Houston, Texas.
You can come to the Car Hacking Village at DEF CON and help us hack some stuff.
The NMFTA call for collaborations is still open. You can submit proposals to work with fleets on cybersecurity topics that they think are important to them and to the industry.
Absolutely.
And they can come to the Car Hacking Village. We're going to probably have a truck there, maybe?
We might even have a
We had one at GERCON.
Oh, nice. That's good. That's very good. Well, hopefully you won't shy away from the next pen test now that you know how all of this works.
And hopefully you won't treat it like an IoT pen test. Thank you.
Thank you.